Good morning, good afternoon, good evening, everyone, wherever you happen to be joining us from today. Morning for me. Super excited to have you all here with us today for another live stream from the Believe in Serverless community, where we talk about all fun things happening in the world of serverless. Before we get into today's incredible guest, I just wanted to talk quickly about other things that are happening this week in the Believe in Serverless community. There is actually one other session happening later today, and that is where Alan and Andres are going to have a deep dive into App Studio. If you're not familiar with App Studio, it was a recently announced generative AI app builder that AWS announced at the New York Summit. I have my own opinions, of which I will not share here on this live stream, because that is not the point of today's session. Today's session, I am excited to welcome, and if I can just work out how the live stream works, there we go, to welcome Mahmood to the live stream. Mahmood, welcome.
Thank you for having me. Super glad to be here.
Awesome. Just for everybody watching along, do you want to just do a little quick intro to yourself, your background, what you're up to, what you're interested in?
Okay, so I'm Mahmood. I'm a software engineer, and I currently work as a developer advocate at Neon, where we do like managed Postgres, and we can talk about that later. Yeah, in terms of my background, I would say I consider myself on the product side of things when it comes to building things. And that's why I was super excited when I heard about this podcast, because now I'm like, oh, serverless. And for me, it makes things easier. It just works. Everything's taken care of. But yeah, this is like I play around with tons and tons of services, and I have a lot of opinions. So
I
happy
love it.
to talk about them today,
Let's
for sure.
definitely get into that. It just works. I think I remember the first time before I started building with serverless, I used to do a lot of like deploying .NET applications to Windows servers and SQL Server databases and all that kind of stuff. And just the pain of doing all that kind of stuff. And then I remember the first time I used Lambda, and I was like, "Ooh, okay, this makes my life easier." So yeah, I was a DBA once upon a time, so I'm particularly excited about today's session, because I've been through the pain of operating and managing and dealing with all the other non-sexy stuff that comes with building applications that use databases. So yeah, let's actually start. Obviously, this is the Believe in Serverless community, so I'd be interested to get your thoughts on what serverless actually means for you personally. Obviously, there's a lot of opinions flying around on the internet. We had a bit of a laugh just before we came online about the whole scale to zero thing. So I'd be interested to get your opinion on what serverless actually means. What are the benefits of serverless?
Okay, so I don't know. For me, honestly, the term serverless is a bit overloaded. It is used to describe many things, and I would say it can mean multiple things. But the idea is that things should just work, and you don't really have to think about infrastructure. Now, when it comes to like what comes after that, it's like it depends on each service, because you have, I would say, like what Lambda was kind of like the pioneer, the first serverless offering, and they popularized the idea of, oh, well, it automatically scales. Everything just works. You only focus on the code. No, you don't focus on the infrastructure. And from a billing perspective, well, you're only charged for usage. So any time where, let's say, your functions aren't running, well, you're not paying for anything, and you're actually just paying for request and execution time. Now, the thing is, it's like this makes sense in this context, but then you have, let's say, in the context of a serverless database, well, things get a little bit tricky, because ultimately a database, well, you have not, it's not just compute where you're running, let's say, a bunch of code. You have actual state. So there were attempts to, let's say, okay, you charge per, let's say, queries and reads and writes, and it kind of works. But then you have another kind of like challenge of like, okay, well, how do you know what your usage is going to end up like? So I don't know. It solves the problem of like, okay, you don't have to worry about infrastructure, but and it's more efficient. But on the other hand, you kind of lose a little bit of the predictability aspect. So I don't know. That's why for me, I just prefer saying like it functions as a service, and let's say it just kind of works or it scales. And for me, I'm like, I just hate using one a big umbrella term where you just like slap it on whatever. It's like this thing is very serverless. But yeah, it's like I don't know.
Yeah, I mean, I quite like the heuristic of if you have to put serverless in the name, like Open Search serverless or Athena serverless. I'm like, okay, if you have to tell me specifically it's serverless, then I'm not so sure. As opposed to it just being, like you say, a managed service or um, I just quite like the idea of it removes operational responsibility. I don't need to care about the infrastructure things. I can write some
Yeah.
application code and it just works and it's lovely. It is interesting with databases though, like you said, because once you get into, particularly into like the relational database world, you almost, at least historically, you almost immediately give yourself a whole load of other things to think about. Because if I'm building an application, I don't know, with, let's just say API gateway, Lambda, and
Yeah.
DynamoDB, they're the only three things I need to worry about. But once historically I wanted to introduce like a Postgres database, that suddenly gives me a whole lot of other things to think about. I need to become a network engineer, don't I?
Yeah, I mean, it's tricky, right? Because I don't know. I always think of, let me actually share my screen because I have a cool diagram I want to draw live and we'll see. So ultimately, the way I think about it is you have this sort of like spectrum, and on the left, you essentially do everything. And on the other side is like do as little as possible, pretty much. And the thing is, every single dev tool service will fall under, like either leaning more towards this side, somewhere in the middle, or let's say do little as possible. And the thing is, especially with databases, well, you kind of have do everything. So, like you mentioned, your background, you've been a DBA before, you know the amount of steps it takes for you to essentially have a working database that is ready to use. And for me, I'm like, okay, if you have, let's say here, like 25 steps to take care of, well, here you'll, let's say, for example, only have 5. And that's ultimately the value proposition of all of these services, because you can have, let's say, an EC2 instance, set up Postgres on it, and you have your database and it works. Some people actually do that where they manage everything. Or you can use, let's say, something like RDS. And RDS works, but the thing is, RDS, it still isn't at the do as little as possible side of things because it's somewhere in the middle. It's somewhere like, let's say, around here, maybe. Uh, because they do take care of a bunch of stuff regarding the infra side of things. Like, let's say, I don't know, maybe they have automated backups. You don't have to install Postgres yourself. You just pick a version and it kind of works. You just have the connection string. But then once you actually start integrating with your application, let's say you're trying to use Lambda with RDS, well, you kind of can't. You need to, like, it's not when you can, of course, but it's like it's not out of the box experience where you just have it and it just works. So that's why RDS, it's not serverless in a way. And yeah, but then other than that, it's like you have these other steps, or let's say you're using something like Lambda. Well, because the database, Postgres by default, it doesn't allow for a lot of connections because it
Hmm.
was designed to be connected from a long running server. Well, you're going to need to introduce another layer between the
Yep.
database and your functions. I believe will be RDS proxy, and you have like a connection pooler. Otherwise, your database will run out of connections very quickly because every time a function runs, well, you're going to spin up a new
Hmm.
instance, and that will create a new connection to the database. So like
Yeah.
that's where I'm like with databases. I personally look at every single service, and in my mind, I try to map it on like, okay, does this do everything for me? Like, do I do as the developer? Do I do as little as possible? Do I just focus on the code, or do I actually have to worry a little bit about the infrastructure, or do I have to manage everything when it comes to the
Yeah.
infrastructure? So like that's kind of how I think about things. And the thing is, because when you try to use an overloaded term, the issue, in my opinion, is you have each developer has their own expectations based on their background. If you have someone that is used to, let's say, managing servers, they just run everything themselves and
Hmm.
they have so much knowledge about networking, making sure, let's say, everything is up and running well, maybe even horizontally scaling things themselves and managing all of this stuff. Well, to them, it's like, what do you mean by serverless? There's always like a server. Like, where's the code running? So for them, it's just confusing. For other people, it's going to be like, oh, well, if you have a serverless database, then I'll only get charged, I don't know, per query or something.
Hmm.
Or so I don't know. That's why for me in general, I like the philosophy of it just works. I don't
Yeah.
like the side of, oh wait, well, it kind of is serverless, but it kind of isn't. And that's why even with Neon, we actually initially started by saying it's serverless Postgres, but we've just found that it doesn't really click for a lot of people. It clicks for some, clicks for other people. Some people have different expectations, but now we're like, okay, it's just called what it is. It's just managed Postgres, and it worked well because it's like it's managed Postgres plus extra stuff. So it's kind of like if you think that this is, let's say RDS, well, Neon, what we do, I would say it fits a little bit, kind of like right here. So
Hmm.
that's where Neon
Yep.
would be. Because again, there's still other, I don't know, like in my mind, this is just the database, but you're not just building data. You're building an app, you have multiple services, you're combining things together. So what happens, again, in my mind, I'm like, if I want to go from, let's say, development to production, there's going to be this massive list of steps that I need to do. And if, let's say, you're using a backend as a service, well, it's going to abstract away a bunch of these steps. Neon is just a database. So I'm
Yeah.
like, that's why it's not like, in my mind, as the do as little as possible. You still have to bring in a bunch of extra stuff
Yeah.
so that you actually have a working app. But yeah, this is kind of my mini rant about
Yeah.
why
I mean,
I didn't like the term. But yeah,
I completely agree. I've been trying to, I suppose, for the last maybe 12 months, trying to talk about this idea of a spectrum, because I think
yeah,
I think the other thing that you get into is when you start talking about things being serverless and you have that rigid mindset of serverless has to scale to zero, serverless has to do this, then that's where you end up getting in these kind of debates about whether something is serverless or not. And it's completely besides the point. Like, it is besides the point. Like, if I'm going
yeah,
to use a managed Postgres offering versus RDS versus database on EC2, like you say, I have to do less things with the managed database than I do have to do with EC2. And that should be the conversation is, do I need some really random, unique feature of Postgres that's only available if I manually run Postgres? Okay, then do that. You think about it
yeah.
from like the compute perspective, if you're running, there are reasons to run Kubernetes, and I think this live stream might just get cancelled if I say that word too many times. But but there
I mean,
are
there,
there are
there is managed Kubernetes, so kind
yeah,
of,
absolutely.
but yeah,
When I was still working at AWS, there was a heuristic that I once heard that was like, if your ability to dynamically scale infrastructure is a core differentiator for your business model, use Kubernetes. I'm like, yeah, okay, I like that, but that's not an awful lot of companies. So there's a lot of companies who are just building apps where there's no, I don't know. I think we could go off on a whole other tangent here on a rant about serverless and compute and all that kind of stuff. But I think it's the same idea, isn't it? There's reasons where I would want to take on more responsibility, where I would need
yeah,
Kubernetes.
yeah.
But I always like to think of things, going back to your idea of a spectrum, always try and start as far right on this spectrum as possible. I like your diagram. I want to do as little as
Yeah.
possible. And then if I need to, I'm going to step out to RDS. If I need to, I'm going to step out to
Yeah.
ET2 if I need to.
Yeah, that makes sense to me. Yeah, because I kind of at Neon we use Kubernetes in the background for our
Mm-hmm.
service. Like, okay, that makes sense to me. But for me, as someone who wants to build, I don't know, an application, and it's not this complicated, then
Yeah.
I just want to use something where the infrastructure is taken care of for me.
Yeah.
So
Yeah.
that's kind of how I think about
Yeah, I
things.
completely agree. There was when I was at AWS, I was working with a company who built this whole multi-region container abstraction, multi-region, multi-cloud provider abstraction on top of Kubernetes. So it's all Kubernetes under the hood.
Yeah.
And then at some point, it got to the point where I'm just like, why did you not just use Fargate? Or why did you not? Like, there was no need.
Yeah.
Like, I can see a use case for Neon to use Kubernetes behind the scenes, but they're just building like internal line of business applications, and they've spent millions of dollars building this abstraction on top of Kubernetes. It's like, you should have just used App Runner. You should have just used Azure
Yeah.
App Service. You should have just used Google Cloud Run. Like, there was no need to build this application. But yeah, it's interesting what
That's
happens out
also
there in the
another
wild.
thing, right? Because in some people's perceptions, like, oh, serverless means Lambda, but you, like you mentioned, you have like
Mm,
serverless containers as well. And then it's like, wait a second. So it's like, what do you mean? And that's why for me, honestly, I just be like, hey, it's fully managed. And
yeah,
if let's say like a serverless container service, I'm just be like, hey, you just to have an app you deploy it without worrying about the infrastructure. Like I'd
Yeah.
rather be wordy and specific than try to be concise and confusing.
Yeah,
That's
absolutely.
kind of how I think about it.
Yeah, absolutely. So let's talk a little bit more about Neon then. So
No.
give me, I suppose, the what is Neon? Like
All
I
right.
mean, you've alluded to it a little bit, but like what is Neon?
Okay, let's do the 30-second elevator pitch pretty much. And the idea with Neon really is it's Postgres, it's managed Postgres, but you have a bunch of extra features that help you ship faster. And if I were to summarize them, really, it would be that with Neon, you have three kind of core differentiators or ideas. The first thing is it auto scales. So when you don't have to pick a size for your database up front, and you don't have to really worry about how much resources am I allocating. All you do is you define the minimum size of the database's compute and the maximum. And based on the actual application usage, the number of queries, how much work the database needs to do, resources will be automatically allocated. So you technically don't need to worry about the details of, okay, I picked this size for my database. Well, is this enough? I need to monitor the utilization. I need to upgrade to a bigger instance. You technically don't have to. You can just pick the minimum and the absolute maximum, and it would just work. And you would only pay for the actual size. So if I were to simply explain it, it's like you're paying for the compute time that's running at each specific size. And that's where things get a little bit confusing, because if, let's say, you have, this is your database compute utilization.
Mm-hmm.
When you're using something, let's say like RDS, well, you just pick a size for your database upfront. So you're going to be like, okay, I want here to be like, I don't know, 1 G CPU and 4 GB RAM, for example. So this would be regardless of the querying, whatever the database is always on, it's always running. And what this means is you're going to essentially be paying for this much, regardless of your usage. But with Neon, it's a little bit tricky, because now it's like you have different sizes, and assuming that here, this is, no, I don't want, I want to have a 0 here. Assuming that this is 0, then what happens is, well, you can have, actually, so Neon actually does scale to 0. So the database compute shuts down when it's not in use. And ultimately what happens is, if this is your actual usage, actually I want the pencil to be easier. If, let's say, this is the actual usage, you have peak workloads, then you have not so much, and then you have a bunch of workload, and then let's say this is the weekend, and you have nothing, and then it scales back up. Well, you're going to be paying only for all of the actual usage. You wouldn't be over provisioning. So that's kind of one of the core differentiators. So it's like, it just works in this sense. You don't have to worry about the size of your database. Storage also automatically scales. So you don't have to be like, okay, I want a 50 gigabyte database. You don't pick from like a series of templates for your database. I will just show it at the end. It's like you just create a database, you have the connection string, and you can just get started.
Yeah. So on this whole, stay on this whole auto scaling thing for a minute then. So let's imagine I get like a sudden huge burst of traffic for whatever reason. Something's gone viral on the internet. What's kind of speed are we talking about to scale up? Like, how does that scaling behavior actually work? Because, one of the quite commonly touted issues forever with any kind of serverless compute is cold start. So if that scaling behavior needs to happen, or that scale to 0, let's say my database is scaled to 0 and it needs to suddenly spin up, like how does that kind of work? Are we talking like seconds, minutes, hours? I'm assuming it's not hours.
So no. It actually takes, so if, let's say, you have, so the default behavior is the database shuts down when not in use after 5 minutes, and you have full control over this behavior. So you can change the time. Let's say, like, we call it like the auto suspend delay. So instead of 5 minutes, you can have it 10 minutes, for example, or longer, or you can disable it completely. So in this case, you will just have the database's compute running 24/7.
Yeah, and that would be at the minimum, right? That would be whatever you set as your minimum level. That would run at your minimum.
Pretty much, exactly. Yeah. And the thing is, if you have scale to 0 turned on, which is a default, Well, the time it takes for the database to spin back up is actually around 500 milliseconds. So
Oh wow. Okay.
yeah, that's like if you have like the thing is if you like this sort of thing matters doesn't matter a lot in production use
Yeah.
cases because typically you'll have the app running all the time.
Hmm.
Maybe if you're building some sort of internal tool, the app might not be frequently accessed during the weekend, hopefully. Then this case, okay, you're getting the benefit of having like the compute shut down. But this actually works better for non-production workloads, which
Yeah.
is
Yeah. Yeah.
Neon's number two use case, really. And with
Mhm.
Neon, really, it makes it very easy for you to spin up, preview, test, um, like preview databases, and each database actually has the both the schema and data. So let's say you have a database that has 1 terabyte that's your production database. Well, you can create copies of this database, and the copy will have all the data and the schema, and it's actually completely isolated. And I'll show that in a second. But the idea is, well, let's say you're using preview deployments in your CI/CD. So for each pull request, you're spinning up an isolated production-like environment. Well, you can do that also for your database. Now, if you're not using Neon and you want to achieve the same thing, well, things get a little bit tricky because if you were to, let's say, create a database and load it with data, well, depending on the size of your data, well, it will take a really long time. Some teams, what they do is they just have a staging database, but that doesn't work well because now you're in the situation where everyone's like, "Hey, everyone, hold up! Do not
Yeah.
touch the staging database. I'm testing my changes." And then you have to do this sort of little dance and where you coordinate with your team, where like, "Okay, hey, I'm doing this," or let's say the staging database goes down. Well, now everyone's previews goes down as well.
Yeah.
So we
Yeah.
solved that issue completely, where it takes around a second. Probably less, but let's say it's a second to copy your database. And that's because we're doing like a bunch of like engineering magic is what I like to call it. But it's just a different architecture because Neon is Postgres, but we have the compute and storage layer actually separate. So
Okay.
in the typical Postgres, if someone you're, let's say you're a DBA and you're in your mental model is you think of Postgres as a server that's running where you have all the resources in one box. Well, in Neon, it's a distributed system where you have the storage and the compute separate. So compute, you can think of it as this is what runs Postgres, and that's why we can actually shut it down. Because again, if you tell someone like, "Hey, the database shuts down," they're going to be like, "Okay, but what happens to the data?"
Yeah. Yeah.
That's where it's like it's different on Neon, but you still get the same exact experience when you're running Postgres, pretty much. Like there might be a few features that aren't supported, but if they're not, we will support them eventually.
And I
But
guess
that's kind of
that's what gives you that 500 milliseconds spin up, right? Because I guess all you're doing is
great.
spinning up the compute layer. You're not having to like hydrate a disk with all the data that's been in a
Yeah,
backup. Like you're just spinning up a compute layer and then bang, and then you're in there.
pretty much.
Yeah.
Yeah,
Oh, that's really like one of the things I remember when I was a DBA. I think the company I worked for at the time, we went down a different approach where we just like, let's say Mahmood needs a database for testing. We just like back up and restore the database. So you end up with like production database underscore Mahmood underscore James
yeah.
underscore Alan underscore. Then you end up with all these databases, and eventually you'd be like, right, Mahmood, are you still using your database? Can we clean it up yet? So yeah, the fact you can spin up preview databases really quickly, that seems very cool. And yeah,
But yeah,
I agree with you on the cold start point, Mate. I think in production workloads, it's kind of less of a problem than I think people make it out to be. Please don't cancel me, social media, for saying that.
yeah, no, I think it's fine. I think
Yeah,
it's
no,
fine.
yeah,
It's
yeah,
kind
yeah,
of why I think about it. It's like with auto scaling makes sense for production workloads. So your app, like I don't know, in my mind, all of these features, the end goal really is you ship faster. They also ship better apps. So if you have your database that doesn't auto scale, and you actually have peak workload in your app, let's say it goes viral, well, the database will become a bottleneck because it
hmm
doesn't auto scale. So now you will have maybe queries failing or performance will be like actually not 100%. Things will be slower for other users. So with auto scaling, like, yes, you have the added benefit of you don't have to worry about the infrastructure, but the end result is your app will behave better and work better for your end users. So that's kind of why I don't know, like at Neon, we think of our customers' customers in a way. We're like, okay, this helps their end users get a better experience. And for the preview database thing, well, it helps you ship fewer bugs because, again, the added benefit of working with production data is, well, if let's say you're doing a schema migration, you know it will behave with very like high degree of confidence when you actually deploy it to production, like all of your schema changes, because you
Mhm.
tested them against production data. And that's why, like, whenever you're you get whenever you become bigger as a company, you will want to, not like you want to move fast and not break things because you have an actual business. So in this case, if you're ever trying to do any change, well, you typically will be discouraged from shipping any breaking change. So you're going to have to maybe be like, okay, we're going to have two columns, an old column
Yeah,
that will
yeah,
keep
yeah,
it in a new version. And like, you don't have to do all of that because you can know that whatever change you want to introduce would work. So that's kind of also part of our philosophy. But
yeah.
yeah, and then
It's the cool.
there's, yeah.
I was gonna say it's the cool thing about the auto scaling. Like it helps in both directions, doesn't it? It helps in your production workload where you get a burst of traffic and you can deal with that burst of traffic, but it also helps in your development. The scaling down helps in your development scenarios
Yeah.
where I can be working on a new feature. Oh, I get called into a meeting for 3 hours. Okay, well that database I don't have to delete the RDS instance and wait for it to spin back up
Yeah.
and spend 20 minutes sat waiting for it to start up. I'm assuming Neon in that 3 hour period where I'm sat in a meeting is going to scale to 0, providing I've got it configured right. And then when I come back, 500 milliseconds and I'm back to work, right? Is that roughly what you'd kind of expect in terms of a developer experience?
Pretty much. Like the thing is, let me now let's actually do demo time. But also
Okay,
there's
yeah.
actually another third feature, and it's
Okay, yeah.
related to like restore, because in Neon we have our own custom storage layer. We also make it possible for you to restore your database back to a previous state in like a second, regardless of its
Hmm.
size. So if you were in the unfortunate scenario where you have to restore your database, production database, back from a backup because there was like an issue, typically it can take multiple hours if
Hmm.
you actually are working with a big database. But in Neon, it takes like a second also. But
Nice.
that's like
I've
for
once been the company I was a DBA for. Sorry to interrupt, but I once
part.
they built like backends for like e-commerce websites, and I once
Yeah.
wiped out every single product title and description from every
Oh
single.
my
I
god.
feel like every DBA's got a story. Every DBA I ever speak to have got a story
Probably.
like this where they've like dropped something they shouldn't have done. And yeah, it was like 4 or 5 hours of work to like find the right backup, restore the backup, get it back in place. It took forever. So that
D-
resonates.
yeah. Exactly. I think it's like with Neon, you can also like the way it works on Neon is a little bit different because in a traditional, let's say, managed Postgres instance, they give you backups, let's say, every 24 hours, and they do it automatically for you. With Neon, you can actually pick, let's say, the exact second to which you want to restore your data to. So if, let's say, I don't know, I deployed a change 5 minutes ago, you can be like, okay, let's go back 6 minutes ago. You
Hmm.
don't have to wait, restore, pick the right backup. Let's say you pick the wrong backup. So now you do double the work and you
Yeah.
wait for it and you're just praying that it's right. Like all of this stuff. So I would say these are the three core kind of like differentiators in my mind. It's like you have the preview databases, auto scales, and you also have instant restore. But yeah. So yeah, this is, I don't know, this is the overall pitch. Also there's like the cool things like with RDS, like we mentioned, you need to have RDS proxy. If you're using serverless, with Neon you have connection pulling out of the box,
Yep.
and it's really like it works really well with serverless deployments. We even have like our own serverless driver that we built so that you can connect to your database from all the serverless environments, because some of them you couldn't actually connect to the database directly. But yeah, anyway, so this is the Neon console. This is what happens when you sign up on Neon at neon.tech. And this is what you'll see. I have kind of like a fresh new account. You should be getting a similar experience. It will probably be like less zoomed out. And what will happen is it will just you'll have like a big globe here. I'm just zoomed in. Also, wait, is my keyboard disabled?
Yeah, I can't see anything that you're typing.
I think it is. 1 second. Huh, that's weird. Well, okay. Well, let's say that now I'm going to be in the Neon console here. What I was saying is like you'll have this big globe, but I'm zoomed in
Yeah.
so everyone can see. And essentially in Neon, you have the idea of a project. And you can think of a project really as a container for the different resources you can provision. And you typically, what you do is you have a project for every application you're working on. So let's say you're building an API. This API needs a database. Well, you're going to create a project for it. And let's say for this project, let's call it, I don't know, something meaningful like demo. And then you'll choose a Postgres version. And then you can also pick a name for the database that will be created.
Mm-hmm.
And then you choose the region for your database. Now, you should pick the region that's closest to where you're deploying your app, so that you have like the lowest latency. So if you're deploying, let's say in Europe, well, you should choose the Europe region. And if you're using, let's say, I don't know, if you're deploying to US East, you can pick US East or whatever. I'm based in, closest one for me is Europe, so I'll just choose that one. And for now, this actually runs on AWS. So if you're deploying your app to AWS, you should get the best latencies.
Mm-hmm.
But yeah, so
how would, let's imagine, just so I understand this whole like this project container, then let's say I'm on a team and the team I'm working on is responsible for, I don't know, 4 services. All 4 services need a database. Would you have like a project per, I'm going to use the word microservice, but a project per microservice? Or would you kind of, how would the project container be like a permissions boundary, whereas me and you were on the same team, so all the databases our team are responsible for are in the same project, or is it kind of, is there no best practice in that scenario?
So there is. So if the goal is, do the services share the same data, or do each service need their own database instance?
Each service needs its own database instance. They don't share data.
Then you'd create a project for each one of them.
Okay.
Pretty much.
Yeah.
So
okay.
The thing is, this is a Postgres specific thing, where with Postgres, you have a cluster. And within this cluster, you have many databases. So whenever I say database, I just say I'm referring to a cluster. But technically, a database in Postgres world is kind of like a folder, and you can have multiple databases on the same instance. You can think of a project in Neon as the equivalent of a cluster. So that's kind of how it will work. And yeah, but yeah, it's like in this situation, we actually, once we created the project, we have the connection string, and this connection string works. Actually, it took like a second to create. So unlike, let's say, something like RDS, where it's just like, oh, you have to wait for it for like 20 minutes. It actually just, everything here is fast in Neon. You just copy the connection string and you're good to go. And I think we can, we can use this connection string. Let's say we can connect using pSQL, but whatever. We actually have a SQL editor in Neon as well. So you can just use this one to run queries. So let me actually just run this query. So what this query does, actually, let's see if it zoomed in. So this is like a simple query. All it does really is just creates a table. And this table called playing with Neon. Each table has an ID, name, and value. And we're just inserting a bunch of random values here. And so if I click run, you're just going to see that we created and added a bunch of data. Now, the cool thing is, like I mentioned, once you have the connection string, so let's say we ran this query against the database that was created, and let's say you're using this database for production. So now let's talk about the preview databases that I talked about. So the way it works in Neon, we have the concept of branches. You can think of them a little bit like Git branches in a way, but not really. I would say, because it's not like a one-to-one mapping, but you can think of it, it's a bit similar, where a branch in Neon, you have the data on it. So by default, when you create a project, which you can think of it as the instance on Neon, we automatically represent this kind of like project by a branch. So you have a default branch that gets created. It's called main. And this is what I just ran the SQL query against. And now, if I want to create a copy for another environment, let's say it's development, then what I can do is just click on Create Branch. And actually, if we went through that quick start here after we created the project, we have the concept here of creating a development branch. And you can just create it here. And here it will create a branch for me called dev / and then this is my username. So now I have a different branch that was created. So if I go to branches, you'll see that I have my main branch, which is what you would use, let's say, for production. And now I have this dev branch, And this dev branch is what I would use in local development. So
Mhm.
in Neon, we don't, oh, like it's not just for previews, it's preview testing, databases. Like I like to make the joke internally. I'm like, okay, we think like Neon is like a connection string provider. We just give you connection strings, and all these connection strings either have data and you can do a bunch of stuff with them. So like in Neon, we have like the tables view. So here you can actually view the data that's inside your database. And you can see that here, this is at my account / demo. So this is the project
Mhm.
and then the branch I'm on. And then I can switch between branches. So right now I'm on the main branch. I have a single table playing with Neon, and I have ID, name, and value. Now, if I switch to the dev branch, this is my own one. And what we recommend is having a development branch for every developer on your team.
Mhm.
And what will happen is we actually have the same data. So this was created in a second. Like you saw me, I just clicked
Yeah,
the
yeah.
button and we still have the connection string when we have the same data. But we actually like this is actually completely isolated from the parent branch. So it's like there is you have a branch, and then whenever you create a branch, you have to specify which branch you want to copy. That's why I said it's kind of like similar to Git. And here, the parent branch of this dev branch is the main, the one I'm using for production. But in practice, this could be another branch if you don't want to copy off of production directly, for example.
So if me and you were working on an issue together, for example, and you had your dev branch and you're like, here, James, take a look at this, I could take a branch from your branch and I'd see the exact same data that you were seeing. Is that, am I understanding that right?
Yeah. So
Yeah,
you
yeah.
can think of really as like a branch, like really as a copy. It's its own connection string. So if you
Yeah.
want to connect, you choose which branch you want to connect to. And each branch has its own connection string. So here, this one's for production. You can see the ID here, like EP lingering breeze. And if you go to the dev branch, you'll notice like, okay, it's EP wispy resonance, something like that. So
I'm a
it's
big
completely
fan of these
different.
database. I'm a big fan of these connection strings, by the way. I love
Yeah,
a
it's
bit of
like
randomness in there.
sometimes they're super random.
Yeah.
Like we actually have to like have like a list of random words where so I think one of them was like I don't know like something like delete or like a very word that just you shouldn't use like on a database that's just very scary. And we had to be like, hey, let's just
E-
remove these words from our
yeah.
random ID generator.
EP
But
dash drop table or something like that. Drop database.
yeah, maybe
Nope,
that,
don't
yeah,
want
it's like
that.
yeah, like what? But yeah, that's pretty much it. So like now each one of these connection strings, they point to so like I don't want to get into the internals of how it works. I can leave a bunch of links, but you can
Yeah.
think of it as now each branch is its own database that you can use that you can work with. So rather than having Docker running locally and you spin up Postgres and then you seed it with data, in one click you have a connection string you can use while developing
Mhm.
locally. And this connection string, well, gives you a database that has both the schema and data of its parent. So that's why in the tables page, this is that schema of production, and this was the schema of my development branch, and they're the same. And if let's say I'm going to delete these two records, so record 9 and record 10, and if I delete them, now they're deleted from this instance. So now I'm on the dev branch. But if I switch to production, you'll see that the data is actually still unchanged. So now you have these two completely isolated instances that you can use. They share data and they're completely isolated. So hey, you can drop the table here, you can create new tables. And once you're happy with your changes, all you need to do is just reapply the same, let's say, DDL and schema changes to the other branch. So you can think of the flow really is you start with a branch locally, you make your changes, you have your schema changes, and in a CI/CD pipeline, you should have your schema changes tracked in code, so you
Mhm.
can automate the process of reapplying them, and that's how you can go from development to preview to production. So
Yeah.
this is kind of like the neon way of developing new features when you're working with the database. So
Yeah.
it's not like I like to think of it as more than just an infrastructure, but something that's deeply integrated in the software development lifecycle, where the database isn't just this store that you have to manually manage that doesn't really fit into your typical workflow as a developer. And yeah,
So all of this stuff you've just done then in the console, is all of that available programmatically? Because I think
Yeah.
one of the use cases I can see here, like the amount of times I've written like integration tests for an app where you run the test and then you have to write some kind of clear up script after your test. You've got to keep a track of all the things that you create, and then in your
Yeah.
cleanup, you've got to go off and then delete all the records that you've just created for your database so that your tests are deterministic. So,
Yeah.
so yeah, I know you mentioned doing this in CI/CD, but yeah, I'm curious to see what that would look like from like an actual CI/CD perspective.
Yeah, for sure. So like you can have, so we have the Neon CLI. So it's like Neon CTL, and you can just install and download it. And pretty much you can do anything that's in the console, you can do it in the CLI. And you can just use the same commands in your CI/CD pipeline. And that's essentially how you would create the branches. So I think I'm already authenticated. And here it will show all of the different commands. So you can see that you can list all projects, you can list all branches for a given project, you can list all the databases because so the database resides in a branch because it's like you have your cluster and you have your branch. And if you're going to copy the branch, well, the database itself will be copied.
Mm-hmm.
And let's say if you have multiple databases on the instance, and when I say multiple databases, I mean like here, if you go to the console and you have here this connection string. So the database name itself here it's called NeonDB, but you can create a new database, and this database would be called like test, for example, if you want to. But you really don't need to do that because you can just create a branch if you need like another database. But yeah, like you have a CLI, and the thing is, it's like each branch you can create it as part of your CI/CD pipeline. So let's say you have tests, you can start the test by creating a branch, and then run your tests again that branch, and then you can delete it later because branches are really like disposable. You can just like for development purposes, we recommend that you have like a long running branch. And whenever, let's say that the schema changes between, let's say, the different branches, well, you can actually reset a branch from its parent. So in practice, let's say here in the tables page, we added a new column to the production. Let's say one team member shipped their changes and it adds a new column. Well, rather than deleting my development branch and creating a new one, we actually allow you to go to your branch, so this one, and you can just reset from the parent. And in this case, you actually just grab the entire, you can think of it as just grabbing the entire branch, parent branch, and then just replacing it with yours, but it's in like one click. So if I reset, what will happen is this will replace all of the existing data schema in my branch, and it's kind of like I'm getting a fresh new copy, but it's still my same branch and I still have the same connection string. So that's kind of what we recommend. And if you go to, let's say, the tables page again, and here we have the same 10 records, if I switch to the development branch, I will have the same data again. So you can think of this now, we have this very powerful primitive where you can essentially have a connection string for every environment. Each environment will now have a fully working copy of your production database or another database if you want. And then you can use it to test your features against, develop against it, try out new stuff, and do whatever you want. So like if you have a query that you're like, okay, I'm scared of running this query against production, you can just create a branch, test it, check the data. If you're confident, then you can just do it against production. And if, let's say, it messes up, well, you can restore very quickly. So it's like, it's we care about this stuff. But yeah.
No, I think that whole, like you said, that whole both having the long-lived development branch per developer and the fact you could dynamically, in theory, dynamically create a branch. I could see a scenario where you could, create a branch with the name of the commit hash for that thing going through your CI/CD pipeline, run the tests, tear it down again afterwards.
Yeah.
I see.
So like,
coupled with the auto scaling capability in that when it's not being used, I can have my long-lived dev branch and it's not costing me anything while it's not being used. When you throw all that in together, this becomes like a really developer-friendly, really powerful thing. Because I could just spin up a database as a developer and know that it's not going to suddenly cost my company tens of thousands of dollars because I've misconfigured it. Like it's going to scale up and it's going to scale down, and happy days.
Pretty much, yeah. And the thing is, so this is actually an example of a CI/CD pipeline where we create a preview deployment for every pull request, and along with it, we create a branch for every pull request as well. So now for each preview deployment, you have a preview deployment that has its own database. So like here in my deploy preview workflow, I have, so with GitHub Actions, we have our own GitHub Actions that we maintain, but under the
Very
hood, they
cool.
use the Neo CLI. But the idea is we have a step where we create a branch. And when we create a branch, we give it a name of preview slash, and then I have another step that just gets the Git branch name. So
Mhm.
now let's say I named my Git branch feat slash add login, for example. Well, now you'll have a branch that's called preview slash feat slash add login. So now you can use this. Let's say if like you want to test something or you want to delete some sort of record, you don't have to worry about all this stuff because you know that this pull request has its own isolated database. And then we get the connection string, and then I just deploy. So here this uses fly.io as a deployment provider, but technically any deployment provider that supports preview deployments and
Mhm.
has, a way for you to do it programmatically works very well. And then you just pretty much you create a branch, run any migrations because, as I said, you should track your migrations in code, SQL migrations. You apply them against this branch, so you're confident that things should work, and then you deploy your app, and then you can test and view your app. And if things work as expected, then you just merge. And when you merge, all you do really is you reapply the same migrations to your production branch, and then you deploy your app to production. And this way, it's like this flow works very well because now it's like in development, you're working against actual production like data. And in preview, you also run migrations against the same like new data because every time you create a branch, you can think of that branches kind of like code in a way. They diverge at the point of branch creation. So like now, if I have my production branch running, people are creating like my users are creating records, deleting records, all this stuff. All this is happening, but separately, I have an isolated instance that just has data up to the point of branch creation. So now
Mhm.
I have production like data. It's not like the exact thing because they're not like synced, they're completely isolated. But now you just can confidently ship new features because you tested them. So yeah, this is
Yeah, I
kind of
mean,
an example workflow.
yeah, I think having the GitHub Actions for me personally is like a particularly awesome thing to be managing because like I think trying to when I've worked with other things in the past that only have a CLI and you're trying to work out which order of CLI commands, how do I pass in the API key? How do I get the
Yeah.
database URL after the fact there's just 7 lines of YAML there and you get an output of the step which already has your connection string. Like that's just such a
Yeah,
huge win for me as a developer. I can just be like, right, 7 lines of YAML, off I go. And it's part of
pretty
my
much.
CI/CD pipeline. So yeah, that's
Yeah.
awesome. So one of the
Yeah.
things that, as you've been talking, one of the things that has been coming to mind is around security, obviously a hot topic with databases. So with that whole database branching, imagine I've got my production database and my production database has some kind of sensitive PII type information in there. Is there a way to either like stop people creating branches from a branch, or can you do kind of data masking, or are there any like kind of controls in place to manage that kind of stuff? Or I suppose you see what I mean?
For sure. So we do have a bunch of security measures. Like we're still like this is I would say a work in progress
Yeah,
area.
of course.
But when it comes to data, what happens is you can have so the way it would work is you can do something like this, where let's say you have the main branch. Now I'll just make this black. And then you can create a copy of this branch.
Hmm.
Let's call this one, you can think of it really as a kind of like, I don't know, I like to call it like template pretty much.
Yeah.
And then you'll create copies from that branch. But before you
Okay.
create the copies, you'll modify the data that's here.
Got you.
And now my dev branch will have, let's say, masked data. And there are tools out there that can help make
Hmm.
this process easier, where you just specify, like, okay, these are my columns, this is my database. And you kind of have, let's say, some sort of import process where you anonymize the data for this branch. Because again, ultimately, each of these is just a connection string, we just make it super easy for you to copy your database. So
Got you. So
now
you
this
could
dev,
almost have like
yeah,
a regular task that's creating the template, like as in like duplicating main, running a script to PIIfy all the data, or
yeah,
un-PIIfy all
pretty
the
much,
data, and then you've got like a reasonably up-to-date template that has real customer data, but it's all been
yeah.
anonymized, etc., etc.
Pretty
Very cool.
much. That's kind of what we recommend for now, and we want to make this process as seamless as possible. So
Yeah,
that could mean us adding the feature, integrating with other tools. For now, it's a little bit of a manual process, but
yeah,
once, like, this is one of those things where once it's set up, you just forget it. It's kind of
yeah,
like it just works. Kind of like also like CI, especially for this sort of thing. Like once you have preview deployments, well, you don't really need to make tons of changes all the time. But
yeah.
yeah,
I mean,
this is kind of like
coupled
how
with
it
the fact
works.
you've got all the CLI, you can do all this programmatically. Actually, running a CLI command to duplicate a database, having you write the SQL script once to anonymize stuff, or you use the tool once, set up the tool once to anonymize stuff. So you've just got then like, you use that same thing over and over again. So yeah, I think it's once you've got it created once, you just reuse that same thing over and over again. So yeah, maybe it's a heavy lift
Pretty
initially,
much.
but it's
Yeah,
yeah. Now,
that's how it
just
works.
staying on the security theme then, because obviously again we're talking database
Yeah,
here. Is there any so whenever I've designed, if I think about like the typical AWS architecture diagram for designing a database, like an RDS based system, you would always put your database in like an isolated subnet. So the only thing that can connect to it is another subnet, which then has another subnet, which goes out to the public internet. Is there any kind of, I guess, what kind of protections are there in Neon to stop a bad actor being able to access my database
yeah.
from a security perspective, aside from the whole, obviously, that username, password type stuff?
So yeah, the first measure is really around IP allow list.
Yeah.
So you can have just allow connections from specific IP addresses, and this helps. So like in Neon, we still don't support connecting, let's say, via your own, let's say, private, like kind of
Yeah.
like what's it called, like AWS
Private,
private link or
private link.
things like
Yeah.
that.
Yeah.
Yeah, so this is still not supported, but this is something we're looking into. But for now, the best measure is like an additional measure you can set up is just IP allow.
Yeah.
So you just define a list of IP addresses depending on where you're connecting from. So even if, let's say, the connection string leaks, well, someone still wouldn't be able to connect to your database, and the
Mhm.
connection would be rejected. So yeah, and there's also like when it comes to branches, you can also have that kind of setup where you can whenever. So the default is once you set up specific IP addresses. Well, let's say I'm a developer. I don't want to use like you can essentially have a different IP address for the whole branches. Like if let's say I have a development branch, you don't have to have the same um, level. So like you can see here, restrict IP access to, so you can mark a branch as protected. And when it's
Mhm.
protected, it means you'll only be able to connect from the IP allow list. And this way you ensure that, okay, this branch, you can't connect to it from anywhere pretty much.
Makes sense. But then your development branches could be open to the
Unprotected,
entire
pretty
world
much.
because it's all
Yeah.
anonymous data. Oh, that makes sense. Yeah, I think private link would be like when I think about all the big companies I've worked with, I think once you start talking about IP allow lists, they tend to get a bit twitchy.
Yeah.
But I think if private link is on, if that is something that's being considered, then I think that would be
Yeah, for sure.
that's kind of the de facto, isn't it, to kind of hide
But
stuff.
yeah, for sure. So yeah.
Uh, Awesome. Well, this has been incredibly, incredibly cool. Are there any other things we've missed? Any other features of Neon that you want to talk about or I mentioned
I
before we?
think I think that's pretty much it, really. Like the cool thing is, hopefully you don't have to do it, but if you want to restore your database, you
Yeah.
pretty much select which branch you want to restore. Let's say it's production, and then you can just pick a timestamp, really.
Mhm.
But of course, because it's like PM, and I don't even know because we just created the project. But and the thing is, you can pick the timestamp. Like right now, it's 1 p.m. This should work like 1:30 maybe. I'm pretty sure it can I don't know. But again, you
Yeah.
just pick it and then you just do it. And you have like a bunch of tools to verify that the data is correct. Because let's say, for example, I dropped the table and now I know that the table doesn't exist. So what we can do is actually run queries in the past. So let's say if I
Mhm.
know that 1 hour ago I had the user table, so I'm going to be like, okay, select the first 5 users. It's not going to turn anything now. But if I return to, let's say, 6 minutes ago and I rerun the same query, I will actually get the result. And now I can be like, okay, this is the timestamp, restore my database.
Nice. So
So
it's not even a guess. It's not even like I think it was about 5 minutes ago. You could actually
no, no,
validate.
you
That's
can
really cool.
validate that.
Yeah.
Yeah, you can view like the schema at the specific point in time, but also run a specific query at a previous point in time, which is very convenient.
Yeah. Did
But
I
yeah,
see there as well? You can also do a restore from another branch because I can see a scenario
yeah,
there. I've been in
you
situations
can.
in the past where something there was a issue, there was an outage at I don't know 7 a.m. this morning, but by the time now the bug has disappeared for whatever reason. Like something's happened. There's these weird kind of bugs that only happen once every 2 weeks, and then the data kind of sorts itself out. So I guess you could. Okay, I know there was an issue at 7 a.m. this morning. I could take a replica of production at 7 a.m. this morning, throw
Yep.
that into a dev branch, and then actually, test against that, I suppose.
Pretty much. So like in the SQL editor, if you want, you can actually run queries at the specific point in time from the
Very cool.
SQL editor. Just need to zoom out a little bit. And then you can run the query against a branch at a previous point in time, and that's how you do it. And if you want to restore, well, let's say I want to restore this branch, and it's from its own history. If it's from another branch, well, it's going to be, oh, okay, I want the development branch. I want to copy the data that's from that other branch, for example. And you also have the option to not just copy an entire branch, you can copy up to a specific point in time from another branch. So like in a way, you have like it's super flexible system. I
Mm.
actually want it to be more opinionated because you have like too many knobs to tweak. But the idea really is if you want to, you can essentially like whenever you're creating a branch as well, you can by default you can include data up to the current point in time. So if you can imagine a timeline where we keep track of all the changes happening to your database, once you create a branch, the branches diverge at the point of branch creation.
Mm-hmm.
But you can include all of the data up to that point. So if I create a branch now, I'm going to include all the data up to now. But you can also choose a specific date and time. So if I want all of the data up until yesterday, well, I can now create another branch, and that branch would include all the data up to yesterday,
Very
for
cool.
example. And then you can use it. But yeah, that's pretty much it.
Yeah, I mean, I'm gonna stick my neck out and say I think this is the most developer friendly database I have ever seen because I mean I think it's a really powerful thing because I think when people think about building serverless applications, I mean, like most people and most developers I know understand a relational database and they understand the concepts of relational databases. It's well taught, it's well understood. But then if you want to start building properly, fully serverless applications, you need to start understanding things like Dynamo or Cosmos DB or, all these other database providers that require, I know the first time I learned Dynamo, it completely blew my mind. Whereas
Yeah.
now I feel like with services like Neon, I can still keep all of the nice relational databasey stuff, all the tooling I understand.
Yeah.
And a lot of applications don't need that. Postgres is powerful. A lot of applications don't need fancy NoSQL databases. You can do a lot of stuff with Postgres. So now I've got the ability as a developer to really intuitively and really easily just use Postgres. And then it'll scale to 0 in my dev branch and it's fantastic. And in my production branch, it'll scale up if I get some load. So like this has been truly insightful for me. Like I think I said before we went live, I've used Neon a little bit. I've got an account and I keep meaning to create some content around Neon because I think it's a fantastic service. And this has been super insightful for me just to learn more. Like genuinely, thank you so much for coming on and chatting. It's been awesome to see it in action.
Yeah, I'm super glad. But yeah, that's pretty much it. Like the cool thing is like Neon is Postgres. So if you already know Postgres, zero learning curve. And if you want to learn, you can essentially use the 40 plus years worth of content that's already created,
Yeah.
books, all of the stuff, right? And it's like you know how to model your data, how to work with it.
Yeah,
But,
yeah. Is there? I mean, very very quickly before we close out, is there the Neon keep an up to date list of like the Postgres features that aren't supported? Because I assume there's some like I don't know some really specific knobs you can tweak in Postgres that
yeah.
aren't. Is
Yeah.
that
In the doc.
documented? Yeah. Okay, that's in the docs.
Yeah, we have it. Like there are either some features that are just on the roadmap and we plan on shipping them,
Mm-hmm.
and then other features are kind of like hard to do. Like whenever you're doing, let's say, a managed service, you can't really give like super admin access
Yeah.
with things like that because again, it's like if you need it and you're tweaking, let's say your I don't know, like the Postgres config, then you probably are okay with managing your instance. Like if you want to go this low level when it comes to managing your instance, but yeah, that's pretty
I
much
mean,
it.
this comes right full circle, right back to what we talked about at the start, doesn't it? Like, it just works. Like, think about where you sit on the it just works spectrum. Does your application need you to tweak them really deep internal settings inside Postgres, or can you just
Yeah,
get a database and it just works?
pretty
Which
much.
is
Yeah.
yeah, within a second, within 500 milliseconds sometimes. So again,
Yeah.
thank you very much for coming on and chatting to us, Mood. This has been one of my favorite live streams I think I've ever done. I've learned so much,
Okay.
and
I'm
yeah,
glad.
I really appreciate the way you present, and the little whiteboardy thing you were doing with the little diagrams was very cool. So
That's pretty
yeah,
well.
genuinely, thanks again. Really appreciate it. For anyone listening, this will be on YouTube almost immediately afterwards. I think it takes YouTube a little bit of time to process. So yeah, where can people find you, Mahmood? Actually, are you on
I
socials?
mostly hang out on Twitter. You'll find me. It's like we can comment it. It's like it's
Yeah,
this is Mahmood _
cool.
on Twitter. But yeah.
Awesome. Well, thank you again. Thank you everyone for
Yeah.
tuning in and watching, and we will see you all next time. Cheers.
Bye.